This is a Sony Handycam. And about 3 decades ago, it featured an upgrade that changed the world. It wasn't the screen or the viewfinder, and it didn't replace this thing. It was the battery. The lithium-ion battery, to be exact, which was lighter and more powerful. And it was about to set off a massive change in consumer technology.
Suddenly, Sony had in its hand this product that was selling like hotcakes that it wanted to put not just in the one camcorder, but in every device it could find.
Over time, the price of batteries went down, and the power they packed went up.
And what we know from Wright's law is that the more you make something, the cheaper you can make it.
Fast forward to the 2020s, and batteries had improved in power and cost so much that they helped kick off another electronic revolution. This time, in automobiles. Now, just like with consumer electronics, batteries are helping make EVs more affordable, driving adoption around the world.
You're not driving a car, you're driving a battery. And China right now is the leader in batteries.
China's EVs are already cheaper on average than similar gas cars. And it's no surprise that 4 of the top 5 battery makers in the world are located here. Also, one of them, BYD, has been jockeying with Tesla for years for the title of the world's biggest EV maker. All that success means lots of competition at home, propelling China to look outward for expansion. And while some big markets like the US and the EU have resisted China's cheaper EVs, many emerging markets have brought them in.
They're kind of upsetting the chessboard of global power. No pun intended. Sorry.
That's okay. I love a pun. China's dominance in global lithium-ion has sparked companies worldwide to recharge their own efforts in battery technology, from new chemistry to production techniques, in an effort to disrupt the status quo. And with great power comes, well, a great opportunity for profit.
It sounds like distant thunder. It feels like the sound of money.
When you drive an electric vehicle, that car is powered by the movement of teeny tiny electrons, a clever bit of science that converts chemical energy to electricity. Inside a lithium-ion battery is a system built of layers. The cathode is on one side, often made up of a special combo of metals. And then there's the anode on the other side, usually made of graphite. In an EV battery, charged lithium atoms, called ions, move from one end to the other. And their electrons take the scenic route through an external circuit, creating the flow of electricity that makes the car go vroom, quietly. Between them is the all-important separator, because if the two ends touch, well, you get the picture. And the batteries are filled with a liquid electrolyte, which helps the ions flow between layers. But here's the thing. China's cornered the market on every one of these components. This is Sam Artem. He's a research analyst on the battery industry and knows a lot about the ins and outs of its supply chain.
A lot of people assume that we just dig up the raw materials and then we put them together in a battery cell, right? But in reality, this is a very complex, interwoven supply chain.
Let's take lithium, for example. I mean, it's in the name, right?
So things like lithium can be found in places like salt flats of Chile, the hard rock mines of Australia. Miners extract raw materials from the earth, and then those raw materials are shipped to refining plants, which are usually in China, to be processed into the refined chemicals and the powders that are actually useful for making batteries.
Lithium is refined into lithium carbonate and lithium hydroxide. And this processing step is where China has really created a bottleneck. Just look at how much China controls each part of a battery.
That battery cell gets grouped together into a battery module or battery pack that goes into your smartphone, your electric car, or into a grid-scale battery energy storage system.
In addition to that supply chain, the Chinese government poured hundreds of billions into subsidies for the EV industry.
Basically, as early as 2001, the Chinese government wanted batteries and other advanced technologies to become a bigger driver for the economy. And it was in 2015 when they came up with this Made in China 2025 plan, where they made batteries along with EVs and robotics as strategic priorities for the future.
They started out with public buses, making those electric. They had all kinds of sticks and carrots. It's hard to get a license plate for a new car, but if you buy an EV, you can get one faster. You know, things like that encourage people to buy electric cars. And all of that kind of state support that kind of created this stable environment in which new battery and EV companies could thrive, because they knew that long-term there was going to be demand for the product because the state was behind it.
That sustained support, combined with a vertically integrated supply chain and a talented pool of engineers, helped Chinese battery companies commercialize an overlooked bit of battery chemistry and crack the code on cheaper EVs. Just how cheap? Well, in China, one of the most popular EVs is BYD's Seagull. It's tiny and only has a range of 190 miles. Compare that to one of the cheapest new EVs in the US, the 2026 Nissan Leaf. It has a range of about 300 miles. The difference, though, is in price. You can buy about 3 Seagulls in China for 1 Leaf in the US. And part of that is because the Seagull uses a cheaper battery, lithium iron phosphate, or LFP. FYI, we're about to talk about a lot of initialisms. They may be a PITA, but they are the SOP in the world of EVs.
A lot of the innovation with lithium-ion batteries now has to do at the component level. On the cathode, there was the lithium iron phosphate cathode, LFP, developed by Americans but scaled up by China. It used cheap raw materials like iron and phosphorus, but it had a bunch of limitations. It couldn't store a lot of energy, whereas the nickel manganese cobalt cathode, or NMC, was a lot more energy dense.
Even though NMC packed more energy, the cheaper LFP cells showed promise.
And so chemists began making tweaks to LFP batteries with small chemistry changes, small structural changes, and every year the LFP batteries started to become a little more energy dense. And because China was the place where LFP batteries were finding its most development, they also lowered in price faster than NMC batteries did. So today, most electric cars produced in China are powered by LFP batteries.
And they're still improving. Last year, Chinese companies announced that their newest LFP batteries can recharge in about the same amount of time it takes to refuel a gas car.
That technical innovation goes hand in hand with the supply chain.
But they've hit some bumps in the road. For years, China was investing heavily in domestic EV supply chains. But thanks to overcapacity and price wars, 2024 was the first time Chinese companies invested more overseas than at home. But we'll get to that later. Meanwhile, other players are hoping to disrupt the dominant technology and compete on the global stage. General Motors, founded in 1908, is one of the OGs of the internal combustion engine. They also built one of the world's first modern electric cars, called the EV1, all the way back in the 90s. But GM cancelled the project after heavy losses. Since then, GM's made headway when it comes to EVs. And now they're trying to kickstart a new kind of battery technology.
We've got a chemistry that we think is going to be really competitive. It's a leapfrogging of what they've got in China.
This is Kurt Kelty. He's a Tesla veteran who's been working in batteries since Sony introduced lithium-ion to the world. Now, Kelty and his team are betting on a new kind of chemistry called LMR, or lithium manganese rich. Another initialism, I know.
So this is the final form of the LMR, cathode active material. It contains all the added pixie dust that is going to make it work optimally in a vehicle.
That pixie dust is a new cathode mix that boosts manganese, reduces nickel, and nearly eliminates cobalt. GM claims that the shift in chemistry lowers cost without losing too much range.
So with the Silverado, we're getting 492 miles. That's with a high nickel cell. If you end up using an LFP cell, you're going to get about 350 miles of range. Well, if you use LMR, you're going to get about 400 miles of range. So it's in between them.
GM hopes to launch commercial LMR batteries for SUVs and pickup trucks in 2028. They're also hoping to bring their supply chain closer to home.
What we've been doing over the last 4 or 5 years is trying to reduce our reliance on FEOC-based countries, including China. And the most challenging part has definitely been the cathode material. It's the most expensive part. The graphite has also been challenging. Our intention is to have this all outside of China by 2028.
GM has invested in several projects to build up a battery supply chain in North America. Shifts in policy have cost GM billions and can make it harder to establish a supply chain.
The problem is every 48 years, the United States does 180 and have a totally different policy. The government certainly didn't make it easier on them by changing course every so often.
Mr. President!
This sucker's quick. You know, they're having a hard time, the electric vehicles, and they want us to pay billions of dollars in subsidy.
I don't think the U.S. car companies can compete with China right now, but I think if they have a chance at it, they need to continue to innovate. It's definitely an uphill battle.
GM isn't alone in its experimentation. Startups around the world have raised billions to find the next best battery.
I don't think the future is at all settled, and there's lots of different chemistries. I like to think of them as ice cream flavors. Everyone's trying out different combinations to see what works best.
And it'll take a lot of trial, error, and money to see what new tech actually succeeds. Meanwhile, Chinese battery companies are expanding all over, even here.
So in 2006, Gotion was founded in Hefei, China. But today, the company has expanded into the U.S. market, with the first factory being here in Manteno, Illinois. We are going to be making LFP batteries, or lithium iron phosphate batteries.
Gotion is one of the world's largest lithium-ion battery makers. Its new Midwestern facility will make batteries for EVs, energy storage systems, or ESS, which are used to supplement the electric grid, and this thing.
Let's grab this bad boy, plug it in. That's it.
In the past few years, Gotion built several overseas facilities around the world. And now it's flipping the script on an old American tale.
What are the biggest challenges of setting up a factory in the U.S.?
There's a lot that goes into building a factory. And even a company that has built many factories before, it's not just simply a copy and paste.
When it comes to manufacturing, the U.S. is a bit rusty.
You have to build something from scratch that hasn't been here before, or it hasn't been here in decades. That know-how and technology and that manufacturing experience, that's things that the U.S. used to do. We decided it wasn't important anymore and outsourced it. And that's been the model for the last, 50 years or so.
Enter international collaboration.
It's perfectly possible to make batteries outside of China reasonably cost-effective. And one of those pathways is actually working with the Chinese companies.
Collaboration helped Chinese manufacturers get to where they are today. In the 90s, China implemented the 50-50 rule. Foreign auto firms could only operate through a joint venture with a local company. The car companies expanded their markets, and the Chinese counterparts got knowledge spillover. Gotion's Illinois factory has 300 employees, with plans to scale up to 750 by the end of 2026. This is the man responsible for pulling that off, Mark Krusel.
So I've been in manufacturing my entire life. So ever since I was 23, I see this as a great opportunity to bring this type of manufacturing to the U.S. I don't want to see the U.S. be left behind like we were being left behind.
A key part of the modern American factory? Lots of robots.
So this is a very highly automated plant. Gotion's most automated plant to date. We call it Generation 7. So they had Generation 6 in China, and we have Generation 7 here in the US. The first thing is you get better consistency, better quality with automation. And secondly, we get to reduce some of the manpower cost. So automation is a little more cost effective in the US than in China.
Gotion's expansion is part of a larger trend of Chinese companies setting up factories outside of China to capture new markets and avoid protectionist tariffs. But the company's US expansion hasn't all been smooth driving.
Many people throughout Michigan came to today's rally, voicing their concerns of the company's ties to China and the environmental effects.
3 years later, Gotion's additional $2.36 billion battery materials plant in Michigan is temporarily on hold. The hesitation goes both ways. The Chinese government wants to keep the lid on its technology with stronger export controls on various parts of the lithium-ion supply chain.
China's battery making technology, as well as their EV technology, is world-class. And they're afraid that the US or Europe is going to be able to sort of use that technology for their own purposes, making China less competitive.
Needless to say, this is all very challenging for EV and battery makers seeking new shores. But they may not have much choice.
I always like to think about the US economy and the Chinese economy as sort of like this, one is like the photo negative of the other. Like the US economy is driven by consumption and China's economy is driven by investment in production and R&D. They have all this capacity to make all this stuff, EVs, batteries, and they need to sell it in the rest of the world to keep everybody in China employed. Expanding overseas is really important for any of these Chinese companies because they need new markets to keep growing.
I would say that there's a lot of geopolitical uncertainty making companies a little bit hesitant. However, conservatively, our marketing research tells us that there will be over 500 gigawatt hours of demand for batteries just in the North America region alone. And Gotion definitely wants to be a part of that.
It's not just the US. Demand for batteries is growing globally, which means demand for raw materials. But what if you didn't have to mine all over the world to make your batteries?
We have everything from a small hybrid battery to a large EV battery. Over there you have a shiny battery, easy to dismantle. Other models here are more corroded and more challenging to take apart.
We're doing the coolest thing there is. We are turning waste into important critical raw materials for new batteries.
In Norway, 1 in 3 passenger cars on the road is electric, making it a prime environment for recycling. That's where Hydrovolt comes in. Since the types of batteries can vary, Hydrovolt has to design a recycling process for each kind. Today, they're up to about 200 different batteries. The process begins with D&D. No, not that one. Discharge and dismantle.
Over on this side, we have 6 discharging stations. That's sort of the most critical step, getting the energy out of the battery. And then we move to the dismantling part. We take off electronics, we take off cables, we take off plastic materials. We're in the control room, the heart of this plant. These are battery modules falling into the crusher, ready to be be crushed and shredded into pieces. First, a coarse crushing and then a finer crushing afterwards.
This mechanical shredding process, along with several drying and salting steps, results in a material mix called black mass.
This is a really fine black powder, which contains the heavy metals like the lithium, manganese, cobalt, nickel oxides. So here we are conducting measurements, and the main components that we're looking for is the nickel and cobalt, which is most valuable, so that our customers will know how much is in the black mass when they refine it.
That black mass is sold to chemical companies, mostly in South Korea and Europe, which refine it back into battery-grade material, keeping those same metals in motion from old batteries into new ones in a new circular economy. Another benefit is that it bypasses the troubling human rights record and environmental damage that plague the global mining industry.
And the challenge now is to make the business profitable.
Norway requires producers and importers to pay to have their batteries recycled, but the economics are still tough. Black mass is priced at a discount based on the cost of metal components, which can be volatile. Plus, Europe's battery supply chain, which would form an important customer base for Hydrovolt, has been slow to develop. In fact, Hydrovolt was initially launched to supply Northvolt, a Swedish startup battery maker that was hailed as a viable counter to Asia. Unfortunately, Northvolt went bankrupt after it expanded too fast and delivered too many faulty cells. But as more EVs age and come off the road in Norway, Hydrovolt hopes the increased supply of EV batteries will help the company scale up operations.
We know we're at the very beginning of a very exciting journey. We see all the electric cars outside on the roads, and in 10, 15 years they will be here.
It's hard to believe how much has changed since this unassuming battery was first introduced and unlocked a future we couldn't imagine at the time.
Batteries have changed the world once, and they can change the world again because the applications for batteries are many and growing, and the need for those applications to work is getting deeper because we have to meet climate goals, because we have to cut the cost of energy, and because we like cool devices.
The future is zero-emission vehicles. It's just a matter of when.
That EV revolution has hit a fork in the road, and the pace of adoption is going to be uneven. The US government is betting big on oil rather than ions to move people and goods. And the EU has rolled back their 2035 ban on combustion engine vehicles. But long-term, any car company that wants to be globally competitive needs to make affordable EVs, and batteries are the key to unlocking that goal.